happy Friday, and welcome to Okuma America. I'm Wade Anderson, Product Specialist Manager. Today, we are excited to have you join us on YouTube Live as we've got our friends from Allied Machine and Engineering here. They're going to talk about their TA Pro series of drills and showcase a demo that they put together for us. I'm going to spend a few minutes and give you an overview of the all-new bridge mill, the MB-80V from Okuma. So to get started, let me kick off by introducing Sal. Sal?
Thank you, Wade.
Thank you for joining us.
I appreciate you having us here. As Wade said, my name is Sal DeLuca. I'm a product manager with Allied Machine and Engineering. And today we are going to talk about the TA Pro line of drills. TA Pro was launched in late 2020 of last year with some ISO carbide grades of insert, as well as a completely revamped holder line. So you've got insert sizes from 7/16 up to 1 7/8, holders up to 15 times D. So we're able to do some of the shorter holes, some of the long stuff really efficiently. And not only that, but we're also excited to show off. We just launched yesterday the new X Geometry TA Pro, which is a high-speed steel or a cobalt type insert for the TA Pro product line. So to show a little bit more of these features, I'm going to jump down here. We're going to talk a little bit about the inserts. So from the insert standpoint in all TA Pro, we've got a brand new point geometry design. So we've got this new notch point design, a little bit bigger and wider, so it works in a wide variety of materials. All new lip geometry. Basically everything on the front end of this tool is completely revamped. And then since it's an ISO specific geometry where you've got P steel, K iron, N non-ferrous, and now the X geometry, our ability to kind of combine the best coating as well as the best substrate for those applications, really to make it easier for you to order, has been phenomenal. The other big point to talk about is the holder side of things. So what we've done with the holders is we've got a new proprietary coolant design. So you've got this large main outlet on the outside, which is really what's doing the majority of the chip flushing. And then you've also got this inside coolant outlet that is right there, and it's right up against the face of the insert. And what that does is it kind of creates this fan spray of coolant. And that fan spray of coolant is really what allows us to be able to utilize higher penetration rates that we've really never seen out of a TA product before. Because what's going on is as the chip is rolling off of the cutting edge of the insert, you're getting coolant right up there, and it's kind of creating that thermal shock. So we're able to get coolant close to the cutting edge, obviously for cooling effects, flush the chips out, and maintain good chip formation because of the thermal shock off of that spray at higher penetration rates. So new flute design on these tools as well, added additional body diameters for maximum rigidity across the series. So really just a ton of big improvements for the TA product overall. It kind of combined up into this TA Pro offering. The new addition to the X Geometry that launched yesterday really offers more versatility. So on a machine like the MB-80V, where you've got good high spindle speeds, you can really maximize the efficiency on your carbide tooling. So with like a carbide steel grade, you can run high penetration rates. But when you get into some of these larger parts that you might put on a machine like this, that are maybe an expensive material, or it's large, or you've put a ton of work into it already, and the last couple of holes on there are just bolt holes that you're going to tap to be able to pull it out with a crane, you really don't want to risk anything with that part. So the X Geometry kind of fits in there as that safety drill. It's going to give you phenomenal tool life similar to carbide, but it's also going to give you that ultimate security that you're going to be able to utilize it with good speeds and feeds, have good chip formation, and not have anything go wrong while you're in the cut that may damage the part or cost you, the part entirely. So the X Geometry is really kind of the perfect blend into the TA Pro product line, and we are going to feature it here today. So why don't we talk a little bit more about the MB-80V, the machine itself. I'll turn it back over to Wade so that he can give you a little bit more details about it.
All right, thanks, Sal. Walk with me. Let's join up at the machine. So one of the things that you'll notice as we open up this machine is how wide the machine itself is. So We have a 63-inch long table that's 31.5 inches wide. We have 38,500 pounds of frame that is supporting the table and the spindle. So this is a very large, very strong machine. It is a true bridge style machine that really takes its ancestry from our double column style machines. Okuma started building double column machining centers in the early 1960s. We found that to be one of the best designs to give us strength and rigidity, as well as thermal support for the machine structure itself. So as you look at the machine, you can see there's a double column bridge. The table itself runs underneath the bridge. A couple of interesting things to point out about this machine. One is the massive amount of volume of coolant that we have. So we have overhead shower coolant, then we also have cross coolant under here. So we have a lot of shower coolant and cross coolant volume to make sure we're getting chips off the covers, off the table. And then on each side of the table, we have actual chip conveyors. We're not utilizing a coolant flush or a coil auger conveyor to get chips out of the machine. We've got hinge belt conveyors running down both sides of the table itself to ensure that we get the chips out of the work environment and outside to your chip bin. The ATC on this machine, we can range anywhere from 32 to 64 tools, depending on what your needs are. And then let me touch a little bit on the spindle itself. The spindle is really the heartbeat of any machine. This spindle on this machine is a Cat 50 Big Plus, and it's a 12,000 RPM spindle. We have 302 Newton meters of torque, and we're running 44 horsepower. So we've got a lot of strength, and we've got the mass of the machine itself to be able to support that. We also offer the spindle in a Cat 40 Big Plus that ranges from 15,000 or 20,000 RPM option as well. So one of the things that the Big Plus spindle does for us, this is a tool holder from Big Kaiser. We get dual contact on the tool holder itself. So we have taper contact as well as face contact. So that gives us a lot of strength and rigidity when we're pushing big diameter drills like this, but it also gives us repeatability. Every time we do a tool change, our Z-axis length to the tip of that tool is very consistent. It doesn't change based on centrifugal force and things of that nature when you're utilizing a Big Plus spindle like this. Another key feature I want to point out that we're utilizing on this, so this is a kind of a representation of a semiconductor part. So when you have a big table, we can put a lot of different types of work pieces on the table itself. So in this scenario, we've got a large part where we're doing a lot of drilling. Then we've got another part on a vise. So kind of replicating, you could do different types of work pieces, or you could set up to do progressive type work. You could have an op 10, op 20, op 30, things like that all set up on the table. But for an example, let's say we put a part on here that weighs 5,000 pounds. Our table weight on this is a 5,500 table capacity. So if we had a part on here and we're doing a lot of hog out work, we would put the part on here and we run a software called Servo Navi. So the table will run back and forth in its x-axis, and through the inertia, it will determine how much weight is on the table and if it needs to soften the acceleration deceleration rates to give us better stability and control over the machining environment. And then if we're hogging out work or hogging out material and this part starts to get lighter as we're going, in the program itself we can rerun that Servo Navi routine where again it will run the table back and forth, and through the inertia settings steepen up the acceleration deceleration rates to speed up the machine. So in the part program and the machining environment, we can actually utilize this to fine-tune the machine on the fly to make sure we get the best control of the machine and the part, as well as cycle time. So just a few interesting features about this machine. So to learn more about the MB-80V or any other Okuma product, go to okuma.com. From there you can see all of our distributors. You can find the local distributor in your area, as well as see video content and other material on all the Okuma equipment. So Sal, let me kick it back over to you.
And very similar to what Wade was getting at with access to the Okuma, same goes for Allied, alliedmachine.com to access your information on local field sales engineers, or if you need to contact our application engineering or customer service groups, all that contact information will be right there. So what we are going to do now is get ready to go over to the demos. We're going to show off some of the TA Pro, some of that higher penetration rate with the P geometry, in the A36 block, we're going to finish off that bolt hole pattern. And then we're going to move over to a interrupted cut on a cold rolled steel block with the brand new X geometry, really to show off the versatility not only of the machine, being able to go from higher penetration rates to also pushing this big tool at a little bit slower penetration rate, but the capability of the X geometry in an interrupted cut, where traditionally that can be a little bit of a scary cut with a drill. So yeah, we're going to go ahead and turn it over to the demo now.
And welcome back to Okuma. We had just enough time to kind of shift our cameras around here and get ready to show more of the exciting part, other than just talking about the machine, but actually show some of the chip making and the drilling that you all came to watch. So let me introduce the next cast of characters here with us today. We've got Rob Brown, who is the engineering trainer for Allied Machine. Welcome, Rob.
All right, thank you, Wade. We're excited to be here today to actually get a chance to run our TA Pro product for you. We're actually going to run a few different demos to show you how the tool works, but the part that we're going to be machining in primarily had a lot of work that was done to it ahead of time, so we're going to have Wade kind of walk you through all the milling work that was done to these tools, these pieces, before we put the tools into action. So I'm going to turn it back over to Wade here for a minute. He's going to show us what they did to get this part prepped for us, and then we'll run some parts here.
Sounds good. Thanks, Rob. So the material is an A36 material, so a little tougher to machine. We started using a couple of different tools. Our application engineer, Matt Obel, had 3 different tools that he wanted to give some runtime on. So we started with a 3.15 inch diameter corncob tool, or an inserted mill. This is taking 1.5 inch depth of cut with a 20% step over, so a 630 thou radial engagement, running a 7 thou chip load per tooth. And we're running 500 surface feet, so with the cutter basically being the diameter of pi, we're running 550 RPMs on that cutter. So again, this is a 3.15 inch corncob cutter. We're getting 15 cubic inches of material removal rates with this particular cutter. So now as we step into the second video, I'm going to talk about a high feed mill. So the second cutter that he brought in was a high feed mill from Sandvik. This is a 2.6 inch diameter cutter. This is running a 32 thou depth of cut. This cutter is running at 80% step over, so basically a 2 inch radial engagement on the step over. This high feed mill is running 59 thou chip per tooth, so this feed rate is coming in at about 433 inches a minute. This is running 1,000 surface feet per minute, so roughly 1,500 RPM on this cutter. This 2.6 inch high feed mill is getting 28 cubic inches of material removal rates at this feed and speed. So the next cutter that I'm going to key up is going to be a 3/4 inch diameter solid carbide end mill. This is just a standard 4-flute end mill. This is an ISCAR end mill. One of the interesting talking points about this cutter was we actually used this on a previous demo on one of our double column machines. We did a lot of pocketing and steel. So this cutter had a little over 6 hours of runtime in it already when we put it on this machine. So this is a 3/4 inch diameter. It's taking a full 1.5 inch depth of cut, so using the full flute engagement. We're doing a 10% step over, so running a 75 thou step over. We're taking 13 thousandths chip load per tooth on this, so this cutter is running about 260 inches a minute. We're running 800 surface feet, so roughly 4,000 RPM. We're getting 30 cubic inches of material removal rate with this cutter. So a couple of key things to talk about here is This is utilizing Mastercam's dynamic tool path. So all these motions was done in Mastercam Dynamics. And we're also utilizing the servo navi. So you can see the smoothness of the motion of that machine and that control. So another little interesting tidbit, one of the things that we didn't video, unfortunately, but we did a full depth slot on this using a slotting cutter. This was an 8-inch diameter slotting cutter. So these are the inserts that was used in the slotting cutter itself. It runs 2 inserts to create the width of the slot, so they're staggered inserts. So as I walk over to this machine, let me show you the width of this slot. This was an 1.25 inch width slot at 1.5 inch deep. So a lot of times we hear people think that you have to run a boxway machine, a geared headstock to be able to take big power cuts. This machine, with the dampening characteristics of the weight and the mass this machine brings in, we were able to do this slot doing 250 thou depth of cut with the full width. So that talks to the strength and the durability of the machine. One of the things that carbide does not like is vibration. Harmonics in a machine, if you have run out in the tool holder, if you have vibration in the spindle, dampening characteristics, less dampening characteristics of the machine, and you get vibrations in the machine in the cut, that creates microfractures in the substrate of the carbide and can cause you to lose your cutting edge much more quickly. So the strength and reliability of the design of that double column gives us a lot of strength to be able to do these types of cuts. So now, enough of me talking about the Okuma and the milling side. Let's turn it back over to the drilling and talk about the TA Pro Series. Why don't you step us through some of the drills and the cuts we're going to see today.
All right. So thanks, Wade. So Wade did a really good job of showing you what we did to prep this workpiece to be able to finish it off for you today. I just wanted to kind of point out that this machine, the Okuma MB-80V, did a really good job with all that milling work, but we're going to show you that it can actually do some drilling as well, because a lot of times, remember, you're talking about high feed mills and things like that, especially ones that have a high RPM spindle. A lot of times they don't have the torque to run a big drill.
Torque and the thrust.
Yeah, so what we're going to be running today are 2 different sizes. We have a 3/4 inch diameter, and that's what we're going to run for you first. Kind of finish off, there's a multitude of holes in the workpiece here, and we're just going to do the last few holes so we can show you the tool in action live, as well as gather up some of the chips, show those to you and see what they look like. And then we're actually going to come in with our new X geometry high-speed steel TA Pro insert that actually was just released, I believe, yesterday. And it's going to be an 1.5 inch diameter, which usually for a machine that has a high RPM spindle like what we see here, that 1.5 inch diameter is just really kind of too much for a machine of that nature. This tool runs it great, so we're going to see that in action as well. So to kind of set the table for where we're going with this first application, we're going to be running an A36 material. Once again, the diameter of the hole is 3/4 inch. We're going to do a total depth of 2 inches deep. Now, for those of us who view the metric system, that's 19.05 millimeters, going 50.8 millimeters deep. We're going to run 450 surface feet per minute and 10 thou per rev, which is 137 meters a minute, and 0.25 millimeters per revolution. It comes out to just under 2,300 RPM. And the coolant's going to be set to 1,000 PSI, which is about 69 bars, somewhere in that neighborhood. The holder that we're going to be using is a TA Pro holder. That's the B body diameter, and what we've done with the TA Pros is they actually kind of beefed up the body into different sizes to minimize overhang. And the insert we're going to use is a TAP1 19.05, which is our P geometry, because this is a steel. So once again, to try to keep it simple, what we're doing is it's based on ISO classification. So we're using that P geometry insert. And in that geometry, there's a carbide grade, a coating, and a geometry that's kind of optimized for running in steels. So that's what we're going to be running here. So Matt, if we're ready, bud, let's go ahead. We're going to run a series of 4 holes. Whenever we run through those 4 holes, we'll go gather up the chips, put them under the camera here so you can take a look at what's going on. Matt, are we ready? Let's go ahead and run it. So while Matt's running this machine, I'm going to kind of tell you what the load is here. Okay, so the load, when it comes down, it's running at about 62%. But remember, when we're talking about spindle load on these things, higher RPM, higher feed rate is going to generate a higher requirement from a horsepower standpoint on the machines. None of that's like a big surprise. But if you notice, this is really, really quiet. What we're running once again is 1,000 PSI coolant. What we're using is a Blaser
Synergy 735.
Thank you very much. I knew it was Synergy, but I couldn't remember the numbers. And it's a synthetic coolant. So we're going to gather up a couple of the chips here and take a look at them. Okay, and we just drilled 4 2-inch deep holes there, so that actually went pretty quickly. So we'll take a look at the quality of the chips that we have. Just gather up a couple of them. Now this is good. Now, one of the kind of negatives that we get into with running 1,000 PSI is it scatters that chip all over the place. We just gathered up a couple of them for you here. So you can see you got a little bit of a long stringer here, but the basic chip form that we get is really, really good. A36, for those of you who are familiar with A36 material, you know, it has a tendency to string out a little bit. It's not the cleanest material in the world as well, so the fact that it doesn't make an absolute perfect chip is not the end of the world. What we need to remember is the idea is that we have a manageable chip. It's not going to clog a conveyor, it's not going to wrap around the tool body. 1,000 PSI was easily evacuatable. The load on the machine was a nice steady 62% the whole time it was machining. And there was no variation, and you heard it, it's really, really quiet, so it worked quite well. So now we're going to move on to our second demo here. So for demo number 2, we're going to go and do the exact same material again. We got one more hole to drill on that part, and it's an 1.5 inch diameter, once again going 2 inches deep. For those of you who are in the metric world, that's 38.1 millimeter diameter, or yeah, 38.1 millimeter diameter going 50.8 millimeters deep. We're running 225 surface feet per minute, 10 thou per rev. That's about 68.5 meters a minute and 0.25 millimeters per rev. We're still going to leave that PSI at 1,000 PSI, which is about 69 bar. But this is using that brand new X geometry high-speed steel insert. So this is an 1.5 inch diameter high-speed steel insert to go through this. So that's why, you know, the speed's a little bit slower than what we saw before with the carbide, because of the fact, you know, high-speed steel doesn't run as high as carbide. But what we get with that high-speed steel is you get that nice reliability. It's a nice tough substrate, so we don't have worries of chipping and breakage and things like that. So Matt, if we're ready to run this one, we're going to go ahead and run the 1.5 inch diameter, and once again I'll tell you what the load is. Okay, so here we go. So the spindle load on this one's about 95%. Okay, but remember at the speed that we're running at 95%, that doesn't mean we're using up the entire 44 horsepower that this machine has. All these machines are on a power curve, so whenever those things are running, you got to look at the amount of power that you have available there. And once again, this machine does a really, really good job from a standpoint of, I didn't get you what you need here. These machines do a really, really good job of being able to give you the torque and the power needed to be able to run a tool this big, even at those lower RPMs. So let's take a look at the chips we have here. Now, these ones came out pretty good, all right? Nice big chips. That's what we expect to see out of a tool that's that kind of diameter. Once again, that 1,000 PSI threw everything all over the place. Chip form is really nice. You really can't ask for a better chip form than what we got out of that X Geometry TA Pro. That's exactly what you look for every time you run these things, so it's pretty good stuff. Okay, so that kind of takes us out of the fancy workpiece that got all the millwork done to it.
All right.
Okay, and we're going to move on to the second part of this demo, where we're actually going to run these tools through an interrupted cut. I'm going to flip my little sheet over here so I make sure I'm giving you all the good information. Okay, so for demos number 3 and number 4, we're actually going to do this a little bit differently. Now we're using the exact same inserts again. For the 3/4 inch, it's going to be that P Geometry TA Pro carbide insert. And then whenever we run the 1.5 inch diameter, it's going to be that brand new X Geometry at 1.5 inch diameter. What we're doing here is going to run into a piece of 1045, somewhere around 180, 200 Bernal, somewhere in that neighborhood. And what we're going to be doing is running through actually what I would consider a noticeable interruption. With the 3/4 inch diameter, we're actually going to break into an 1.5 inch diameter hole. And with the 1.5 inch, we're going to break into some 3/4 inch diameter holes. So interestingly enough, it's the same size as what we're running here today. Okay, so what we're going to be doing here with the TA Pro P Geometry, so we're going to run that 3/4 inch diameter, 1.25 inch deep, which is 19.05 millimeters, going 31.75 millimeters deep. We're going to run that same speed of 450 surface feet, or about 137 meters a minute, running 10 thou per rev. Okay, and but that's going to be until we get to that interruption. When we reach that interruption, we're actually going to cut the feed rate from 10 thou per rev down to 5 thou per rev. Because whenever we break into that interruption, we're going to have one margin of the tool still engaged in the cut. The other margin is going to be in air. So we want to try to minimize the tool pressure so it doesn't try to push off into that open side. So it's going to make it so it's going to create a better hole quality by cutting that feed rate down. So whenever that happens, I'll let you know, because I'm going to stand behind Matt here while he's running. And whenever we get to that half feed rate, I'll say, okay, now we're at the half feed rate, because our spindle load is going to go down because we're not pushing the tool as hard. So we'll notice that in the load meter.
Right.
Okay? So Matt, are we ready? All right, let's do this. Okay, so once again, 1045 material using that P geometry, 19.05 millimeter diameter or 3/4 inch. So whenever it's running through the first part, it's at about 60%. Then it goes down to about 30% whenever it gets to the second part of that. We're going to drill a total of 3 holes here. Okay, and you can kind of hear whenever it gets into that interruption. Okay, because of the fact that it destabilizes the tool. It's a completely natural thing to have happen whenever you've got one margin engaged in the cut and the other margin's cutting free. So we're going to gather up some of these chips as well, so you can take a look at them. Okay, because this is a different material than what we were running before. Okay, so this is that 1045 material, about 180 Bernal or so. Okay, and I'll throw those ones out of the way. And bring these over here, take a look at them. Okay, so this is what we got with that tool running in that 1045 material. To bring it up just a little bit. Okay, oh, there we go. Okay, so nice, good chip formation. Now, of course, whenever we get into the interruption itself, it's going to naturally form a chip, because whenever it's an interrupted cut, the chip form's not going to string along. But the chip form was quite good there. And even though we were going through that interruption, this tool still ran fairly quiet. Okay, so that's actually, that's kind of a compliment both to our tool and the machine, because the rigidity of the machine doesn't allow things to get all kind of wonky, because a lot of times whenever you get a lot of destabilization in the cutting environment, you can feel the floor shake and everything else, and it's actually cutting quite smooth here.
Yeah.
So it's going quite well.
I always judge machines a lot of times, put your hands against the side when it's running and see how much harmonics and vibration you're getting versus how still and smooth that is.
Yeah, and we always talk about that whenever we talk about whenever you're checking for chip packing or whatever with our tools, because as you go down, you'll see the load meter start to spike. You'll hear a change in pitch, turns into like a low pitch grumble, and you can feel the machine kind of vibrating. So, and with an interruption, it kind of does the same thing, because it's just bouncing against the side. So we're going to go on into our last demo, and our last demo today is running that 3/4, the 1.5 inch diameter X geometry high-speed steel insert that once again was just released yesterday. So this is pretty new stuff here. So for this one here, we're doing 1.5 inch diameter. It's 1/2 inch deep, because we're going to break into those pre-existing holes with that tool, and then that's all the further we're going to have a full engagement. So once again, from a metric standpoint, that's 38.1 millimeter diameter, 12.7 millimeters deep. Surface speed we're going to run is 225 surface feet at 13 thou per rev, which in metric is about 68.5 meters a minute and 0.33 millimeters per revolution. Once again, using that 1.5 inch diameter X geometry TA Pro high-speed steel insert. Okay, so Matt, are we ready for this one? Okay, so we're just doing, is this just a single hole we're doing for this one, Matt? 2 holes. Okay, so let me stand behind him here so I can give you the load. So we're at about 110%, and it breaks in. Now it's a nice steady 47-ish. Okay, 38, somewhere in that neighborhood. All right. And once again, we cut that feed rate in half here, so we went from 13 thou per rev to 6.5 because of the fact we're going through that severe interruption. And whenever I show you the workpiece for what we did here, you'll understand why we had to slow this down. Okay, so now we're going into the second hole. All right, so once again, the tool touches down. You got that load, it's actually around 50%. It spikes up a little bit when it first touches down. There's my interruption. My load goes down to about 40%, and it's got to go through those existing 3/4 inch holes. Now, this is not on center interruption. These are actually offset on either side, which is why you're getting a lot of noise out of this one, because of the fact this is a pretty heavy interruption. And once again, whenever he's done, we're going to show you what that actually was. But we're going to have Matt grab up a couple of the chips for me here. There you go. Okay, we'll take a look at what this one made. All right, so we take a look at it underneath the camera here. Okay, and you can see here the chip form looks pretty good. You know, once again, we're getting a nice curl out of it, getting a little bit of a cone shape out of it, which is all what you expect to see. Chip formation is quite nice. So that tool worked really well. So while we're still on the overhead here, I'm going to move these chips out of the way. I want to show you what we did here. I'm going to slide this down because this thing's kind of a big hog. Okay, so I'm going to kind of stick my pencil here through this so you can see these holes here were the ones that we did with the 3/4 inch TA Pro P geometry carbide insert. Okay, so that was this interruption. So you can see, and I'm going to try to tilt it up here so you can see the quality of the hole. It's actually not too bad. I know the focus isn't great, but it's kind of hard to get it in focus with a piece this big. The other thing to really take note of, though, is if you notice, there's very little burrs on this here. Okay, so now to take a look at what we did with the 1.5 inch diameter high-speed steel X geometry tool. These were the pre-existing holes. This was my 1.5 inch diameter, so you can see the severity of this interruption because I was running through this one and this one at the same time. So from a stability standpoint, this was actually quite a challenging interruption. And the thing to remember is we did this with standard holders. We didn't have any kind of special guide pads or anything like that to try to keep this tool stable, and it still worked rather well, sounded pretty good. So that's what we've got for that particular piece. And so that's all the demos that I've got for today. And what we hope that you had the experience of is that you got to see the XT Pro P geometry carbide inserts run and the new X geometry that we just released in that large diameter. So I just want to say, you know, thank you to the folks here at Okuma. This has actually been a really nice environment. They've been very welcoming to us, and it's worked out really well. And if you want more information about the TA Pro carbide or the TA Pro, the new high-speed steel one that we have, you can feel free to visit our website at alliedmachine.com or contact your local field sales engineer or local representative, your distributor, if you have some questions, and we'll be more than happy to see what we can do for you.
All right.
So Wade, I'm going to let you take over from here, but thank you. And Matt, great job. Thank you very much.
All right.
Okay.
Rob, thank you guys. You guys are truly the expert with anything that's revolves around hole making. So any processes that you guys have, you have questions on hole making, you know the right people to get in touch with and contact. So a couple of people I want to also give a thanks to is Blaser Coolant. The Synergy 735 is what we ran on this demo, gave us a lot of clarity and ability to see what we're doing easily from the viewer's perspective or the operator perspective looking through the window. Also, Big Kaiser Tooling provided all of the Big Plus tool holders. All of the Okuma mills run a Big Plus tool holder. So Big Kaiser provided all the tool holders that you saw today for the drilling operations. And MP Systems provided the 1,000 PSI coolant system that we're running that fed the through spindle coolant and things of that nature. So big thanks to everybody. Anytime a customer makes a part, it takes 5 to 6 companies working together in some aspect to be able to produce any type of part. So a big thanks to everybody involved. We appreciate you joining us today. To learn more about any Okuma products or to contact us or our distributors, go to okuma.com and be sure to like and subscribe to our YouTube channel to stay in touch with new videos and new content that'll be coming out. Thanks, and we'll see you soon.
Have a good day.